Okay, we're back. We're back with one more rule of exponents, one more shortcut for working with exponents. And that is, so we've done the product rule. Remember, when you're multiplying with the same base, you add exponents, keep the base. The power rule, when you're raising something to a power, you multiply exponents, keep the base. The quotient rule, when you're dividing with the same base, keep the base, subtract exponents. And the zero power rule, that any base to a zero power has a value of 1. Okay, today we're going to look at the negative exponent rule. So, for example, 5 to the negative 1 power. What does that mean? What is the value of that? What do you think? Negative 5? Negative 1? 0? Or 1/5? I don't know. Let's think about where we could generate a negative exponent. How could we get a negative exponent? And again, this idea is sort of tied into the quotient rule. So, for example, we have a quotient problem here, right? It's a division with the same base. If we follow the quotient rule, that says what? Keep that base, take the top exponent and subtract the bottom exponent. When we do that subtraction, we get a negative 1. But what does that mean? We can get the meaning of this if we look at the problem. I probably shouldn't have chosen such big exponents. So 5 to the 6th, there's 6 5s being multiplied. And 5 to the 7th, obviously 7. And like we said last time, what happens when you have a fraction? You're supposed to cancel common factors. And so, what happens when we cancel? Oh. Now remember, canceling is a division idea. You don't get 0 when you cancel. What do you get? You get 1. So 5 over 5, right? Or 5 goes into 5 one time. So canceling all these leaves me with 1 times 1, 1, 1, 1. So in the numerator, I have a 1. And in the denominator, all of them cancel except for that 1. So the real value of 5 to the negative 1 is 1 over 5. Okay. What would be the value of 5 to the negative 2? Because we're going to jump right to the shortcut here, right? I don't want to write out problems like this over and over again, okay? Here's the deal. A negative exponent means I have a fraction. And once I put that in the denominator, that exponent is no longer negative. So, by extension, 5 to the negative 3, 1 over 5 to the 3rd power. Okay? So, the negative exponent rule says any number to a negative exponent, here's our general statement, right? Needs to be rewritten, it needs to be changed. We don't leave, it's like bad grammar. We don't leave bad grammar in a paper if you're turning it in, right? We don't leave a negative exponent in a problem. So any number to this negative exponent should be rewritten as 1 over a to the m. gets into all kinds of complications. So, let's look at this. X to the negative 2 over y to the negative 3. Yeesh. All right, what do we do with this? Let's take it apart, okay? First of all, I cannot use the quotient rule here. How come? I do not have the same base. So I cannot subtract my exponents. What I have to do is rewrite this fraction without negative exponents. So let's look at this numerator. X to the negative 2. That can be rewritten as 1 over x squared. Okay, divided by. All right, we're going to rewrite y to the negative 3 as 1 over y to the 3rd power. Okay, I know you remember. What do you do when you're dividing with fractions? Keep, change, flip. Right? We multiply by the reciprocal of that second number, that second term. All right? Now what? Multiply across. Okay. So this was a lot of work, right? Can we get to a shortcut? Could I go from here to here quickly, right? Here's what I can say. If that exponent is negative, it needs to change position. So if it's in the numerator, it needs to move down. If it's in the denominator, where's it going to go? If it's negative, the exponent is negative. Not if the number is negative, right? There's a difference between a negative exponent and a negative sign in front. But if that negative exponent in the denominator, then it's going to move to the numerator. Now, what am I going to do with this? Well, this x to the negative 2 up on top here has got to move because of that negative. Where can it go? It's got to come down. But notice, this does not start out negative. So it doesn't move, okay? It's going to stay right in the denominator because the exponent is already positive. So what goes up here? Let's change it around. All right, let's say this x squared, that's a positive exponent. It's not moving down. It's going to stay up there. This is negative in the denominator, so where's it going to go? It's going to come up. All right. Remember, this is like a whole number now. So I do have a denominator, but it's a 1. And if I have a denominator of 1, I typically don't write that. Okay? All right. So that negative exponent rule, right? It says what? If anything has a negative exponent, it has to change position. If it's in a numerator, it's going to move down. If it's in a denominator, it's going to move up. If it's not negative, it stays where it's at. All right, so negative exponents. So we're going to add to our list here. We have the negative exponent rule. All right, so we've got 5 shortcuts for working with exponents. Okay, at this point, we kind of change gears a little bit and we start looking at scientific notation. I'm sure you've all heard scientific notation before, right? When do we use scientific notation? Well, we can use it anytime, but typically we use it as another way to represent very, very large numbers or very, very small numbers, okay? Scientific notation is typically some number times 10 to some exponent. Okay, you probably remember this. There's a restriction on this number here. This number has to be what? This number has to be between 1 and 10. Okay? Actually, it has to be greater than or equal to 1, but less than 10. So it can't be 10. Okay, how come? Because 10 would be another power, right? Okay, let me show you what I mean. So we're going to take this number, 567,000. It's a big number. We're going to change it, not the value of it, just the form that we write it in. So looking at these digits, we have to decide on a number that is between 1 and 10. 567, too big. 56.7, that's greater than 10, is too big. So we're going to come right over here to 5.67. Okay, now I have to decide on that exponent. What would I multiply 5.67 times to get this value? And the quickest way is what? We know multiplying by powers of 10 moves your decimal, right? So I would have to move that decimal 5 times. So from here, 1, 2, 3, 4, 5. Okay, so these are equal, right? We've just written it in a different way. Let's go backwards. Let's take a number that's in scientific notation and rewrite it in standard. Standard notation is just a plain old number as we know it, okay? So you know that multiplying something by 10 to the 6th power is making your number bigger, right? So we're going to take that decimal and move it which direction to make our number bigger? To the right, 6 times. So here's 1, 2. I need to follow up with some zeros. 4 zeros, as a matter of fact. And I'm going to double check myself. So from here to here is 1, 2, 3, 4, 5, 6, 6 decimal spaces. Okay. Again, these are equal. They're just written in different forms. Now I mentioned that we can use this also for very small numbers. What's a very small number? A decimal. So let's take this decimal. Yeesh, really teeny tiny, right? Okay. Using these digits, 2 and 5, we have to write a number between 1 and 10. Not 25, right? But 2.5. Okay. Now I've got to figure out what that exponent should be. Here's the deal, right? This is a really small number, so I can't make my exponent positive because that would end up with a big number. So my exponent has to be negative. Think about that, right? We just talked about how a negative exponent can be written as a fraction, and another representation of a fraction is a decimal. So it's kind of related there. So we're going to move that decimal how many times? 1, 2, 3, 4, 5 times, but that 5 will be negative. All right, let's go one more time in reverse. .002 times 10 to the negative 6. Which direction am I moving that decimal? So now I want to go from scientific to standard, to plain old number. I see that my exponent's negative, which means what? I got a big decimal, okay? Which means I'm not moving this decimal right, I'm moving this decimal left. How many times? 6 times. Here's one. I've got to put 5 zeros in front of this number. I'm going to check myself. I started right here. Moving to the left 6 times. 1, 2, 3, 4, 5, 6. Awesome. Okay. All right, so scientific notation, standard notation. Scientific, standard. They're equal. Okay, it's just another way to write this number. All right. Good job. See ya.